Good morning, everybody, or good afternoon or good evening, depending on where you are viewing from. My name is Tony Drake, and as you can see, I'm a senior engineer, security intelligence for the Intercontinental Exchange. I will be your guide today on our journey of adventure and discovery through Yara for mere mortals. So Yara for mere mortals, when elegance and eloquence are replaced with the quick and dirty. So a quick disclaimer, all the opinions expressed herein are my own. Please don't attribute them to any particular employer, past, present, future, real, ideal, fictional, imaginary. You get the idea. I am a Southern storyteller. I use I, me, we, our. But again, please don't take that to mean I am talking about a specific place, with the exception of the slide at the end where I am talking about we're hiring. So a quick warning, technical content ahead. I don't want you to get bogged down in the technical content in these slides. This is a process talk. If you get bogged down in the technical content and things like hex dumps and strings and so on, you are going to miss the forest for the trees and the intent of the talk. I want you to focus on the process. Focus on the fact that I took a thing and I created a rule to find that thing. So who am I? For those of you who don't know me, which is probably most of the people on this call, I've spent over 25 years in security in various roles. I've been in a bunch of different industries, including financial, consumer, pharmaceuticals, and I have been doing things from both the red and blue team sides. So I like to say I am red team trained to be blue team effective, but my heart is in blue team, and that is where this talk focuses. So why are we here? Well, there are a lot of sources out there to get Yara rules. There are Yara Google groups. There are mailing lists. There are people who share them. There are Yara rules on Twitter. There are Yara rules in GitHub. The government sends them in bulletins. Your vendors will provide them as a service. So you can get Yara rules. However, sometimes what you really need is a Yara rule right here, right now, to find the thing that you are trying to grapple with at this moment. And if you're like me, the first time I saw this, I said, ooh, I can write a Yara rule. So I opened up a Yara rule, I looked at it, I said, wow, that is so cool. That is so efficient, that is so effective. There is no way on this earth that I am going to do that. So you're in the trenches, you need to do something. What are you going to do? That's what this talk is about. So before we can talk about Yara, we had to talk about characteristics. We had to talk about them a couple of different ways. First thing is we have to talk about the fact that all Maldocs have certain characteristics that they need to be effective. It has to be delivered. An undelivered Maldoc, I will use Maldoc and malware interchangeably because I deal more with doc malware probably than anything else at this point. But it has to be delivered. An undelivered file is a threat actor's objective not met. They have to have a name. If it's named toxic waste, do not open. Unless you're looking for the morbid curiosity set, probably not a good way to name your malicious file if you want it to be opened. More like invoice, as we'll see later. And as I say, it has to be opened because an unexecuted malware is an ineffective malware for the threat actor to meet their objective. When we are doing malware analysis, we talk about two types of characteristics. We talk about the static, what it is. This is an Excel file. It is 100 kilobytes in size. It was created with version 10, et cetera, et cetera. We also can talk about dynamic. It goes out to such and such an IP address. It downloads this payload. It updates this registry. The good news is that static characteristics are static because they don't change, which is why we're going to focus on static characteristics, because a lot of times malware catch tools, malware detection and quarantine depends on dynamic characteristics, and these can be changed, these can be fooled. So a quick word about tools. The best Yara-enabled tool is Yara or libyara. You can download it from GitHub and compile it on whatever operating system you're using, or download a pre-built version for various and sundry Linux releases, Windows versions, etc. But if you do not have that capability, You can also look at ClamAV. Now, ClamAV is good and bad. ClamAV is good because it does things like scan inside of archives. It automatically handles the scanning and the file listing and a lot of that stuff for you. The bad of ClamAV, it uses an old Yara string engine that was custom written by ClamAV years ago. It does not have all of the cool features and functions that the new Yara versions have. If you want to use this with ClamScan, which is the command line ClamAV scanner, you simply name your file .yar and you give a command line similar to the one I have provided here. Any command line will work, but the key is the database equals, and it points to a file with a .yar extension so that ClamAV knows it is Yara. So now I'm going to tell you a little story about a Maldoc. Once upon a time, in a company not so far away, there was a Maldoc. And this Maldoc managed to get through the email obstacle course and arrive at the user inbox. This user had taken the security awareness training and they took it to heart. They said security was everyone's responsibility, including them. And so they dutifully reported that to the SOC. And when the SOC analyzed the Maldoc, they said, yep, this is a Maldoc. Yes, it got through our controls. And so, yes, it landed in my lap. So this Maldoc was smart. This Maldoc was able to get around all of the methods that we had, including those that relied on execution. So there were specific techniques. I'm not going to go into those because if I were to tell you about these specific techniques today, there'll be a new one tomorrow, and that's all gone out the window. This is static characteristics. We don't care about the dynamic techniques it used to get through. We only care about what it is, what it looks like, and how we can find it. So, of course, this is a talk about Yara, so we're going to use Yara to detect these characteristics. In the case of this particular Maldoc, there were a few things that made it easy to detect. It had a name like an invoice. It was delivered in a zip file, and it was delivered in a zip file that did not use compression. So now we're going to dig in. This is where that technical content warning comes into play. Remember, focus on the process, not on the specifics. So Yara at its core is a string search engine. Yara will find any string, any format, anywhere, anytime, any type of file. So if we're dealing with Yara, we have to deal in strings. So the way I deal with Yara typically is I pull things up in either a hex editor, in this case, a Hex Dumper. XXD is a Linux tool. I am a Linux guy at heart. So on the command line on Linux, XXD will dump a file to its hex equivalent, giving you the ASCII on the right, the hex on the left. And if we take a look at one of the files from this campaign, we can start to find strings that we can use to detect it. Now, if you were looking at this in a network stream, like with an IDS, IPS, or another inline tool like Brozeek or something like that, you you would not necessarily know that this was a zip file. However, we can find out it's a zip file by using the file magic. 504B0304, that corresponds to the text PK. PK are the initials of Phil Katz, the inventor of pkzip. So since we are looking for a zip, that's where we start. If we look at the zip header just a little more, we realize that there's a lot more in this header than just the file magic. So if you see in this case, I've got in light blue the file magic, and in dark blue, I've highlighted a couple zeros. Those zeros are at byte 0x8, which is a compression method, which means this is a zip with no compression 00. So let's look at the zip header and how this works. So you have the file magic, then you have the version 1400, then you have the flags. These are things such as encryption and other flags that relate to the zip file, and then the compression. That is what that full string means. So in this case, since we don't care about any of those values, I don't care what version, I don't care about the flags, I'm going to use wildcards. And so I start with a string of 504B0304, a bunch of wildcards, and a 00 for the compression method. I ran that and I got about 8,000 hits, and I don't have a lot of time to deal with things, and I definitely don't have time to look at 8,000 false positives, so I'm going to add the @0 directive. @0 means start at the beginning of the file, and if it's not there, I don't care. The reason we have to do that with zip files has to do with how the zip file format is created and what it does with its directory structure, which is beyond the scope of this talk. So going down with @0, we got from 8K to 446, but again, the sock is kind of busy. I don't have that kind of time. So let's be a little more specific. In this case, I got rid of the wildcards and I went to the whole zip header. I'm not specifically looking for those values. I don't care about those values, but in this case, all of my malicious files have those exact values. So let's add them to the string. Now we're down to 276 files at one file per minute. We're still talking about taking more than 4 hours. And as I said, the sock is busy. I don't have that kind of time. So we have to drill down further. We know that this zip contains an Excel file. So we add the XLS extension with a no case directive. No case in Yara says, give me any case, any mix, any time. That's capital, lower, camel case, reverse camel case, you name it, it'll find it, doesn't matter. That gets me down to 70 files, but unfortunately not all 70 are malicious. So we have to go a little further. Now, when we look at the naming, as I mentioned earlier, these are named like an invoice. So I started with the INV string for invoice. Again, no case, so that I can catch a capital I or a lowercase I, things like that. That gets me down to 5 files, which is a pretty darn good rule considering I started with 8,000 files. So if we want to look at the zip rule here, I broke it up a little bit to make it easier. The header of every rule starts with the rule keyword, followed by the name of the rule, followed by an open curly brace. The meta section is optional. These are notes. These are things you want to know: who wrote it, why they wrote it. In this case, I added credit to Tyler Hudak, whose rule I used in this rule. And then we get to the string section. This is the meat of the Yara rule. This is where you define the strings. And so then you see I have the zip with local. You see I have EXTXLS for an XLS extension. You see invoice, I changed to the word invoice in its entirety because I also found some cases where it was INV underscore. So I look for invoice as a whole string and then INV underscore as a second string. Double slash in Yara is a comment. Like all good programmers, I try to comment my code. I suggest you comment your rules later because a year later, when you come back to your rule, you're not going to know why you did this, what you did. But if you have good metadata and good comments, you'll be able to figure it out and you'll know whether you need to keep the rule, edit it, etc. Then we get to the condition. This is where Yara functions like a programming language and where the power in Yara resides. That first word, uint320, that is a performance optimization. It's not really necessary, but I left it in just to show that there are things you can do. This actually looks at the first part of the file as a number instead of as a string. The next after the and is zip with local @0. We already talked about that. Now I want invoice or INV because it will be one or the other, not both, and an Excel extension. So looking at the final rule, putting it together and taking out the blocks, this is what a good Yara rule looks like. And at the very end, you see an end curly brace to close out the rule. So let's look at what we did here. We started with a malicious campaign with a single file. We took that single file, we used characteristics of that file and of the zip file it was delivered in, and refined them down to give a high fidelity rule to deal with this particular campaign. So second example is similar to the first. This is Bazaar Loader, February 2021. Some of you may remember this campaign, but in this case, we're going to do it a little differently. We're going to start with a set of files. And this is actually more common than you may think, especially in the more mature socks where you do more of this kind of community hunting, is you get a list via an email or a threat feed or something. Hey, there's a new campaign and it has all these files in it. And you look for those hashes in your environment, and because of server-side polymorphism and file polymorphism, you don't have those exact files, but you think you could have seen the same campaign. So what we're going to do is we are going to look at these files and try to find common strings that we can use from files that we have to find files that are not known. So looking at the set of files, I do the same thing. In this case, I'm going to use XXD, but I'm going to use it a little differently. I'm going to dump each file to a text file, and then I'm going to compare those text files with diff. When, pardon me. When you do this, you get an output that looks like this. The colors are mine. You see that we have 2 hex dumps we have compared, and we get a lot of common strings. This forms the basis of the Yara rule. And you see the rule here. There is nothing terribly special about this rule. You see it's just a bunch of strings that are a bunch of lines of hex. And the condition for all of them. You can also use any of them with strings, and there are a bunch of other directives that you can use. You can see those in the Yara documentation. But the thing that you need to understand about this, I don't know what those hex strings are. I don't know why they are there. I don't know how they got there. I don't really care. All I care about is the fact that this rule finds them. So how does this rule do? Well, it caught all 30 of the known files in the directory where I was working, and that's a lot like taking the test with the answer key. So I wanted to see how it did in real life. Now I have access to a huge corpus of email file attachments that have been saved, good, bad, and otherwise. So I used Yara to scan those attachments, and lo and behold, using an all the strings match, I found 14 files, all malicious. Scanning again with an any of the strings match, I found 19, all malicious, and they supersetted the 14. So the 19 had all 14 in them plus 5 more. So for those of you who looked at the last couple of things and said, oh my God, this hex is giving me a headache, don't worry. We're going to go a little bit more traditional here. We're going to look at an HTML phishing attachment. So I was doing some research into credential phish kits and phishing attachments. You know, the ones they send you an HTML attachment, you click on it, it looks like Office 365. I want your credentials to show you this super secret, super important document. We've all seen them. Well, as I started pulling them and looking at them and classifying them, I found over a dozen different common formats that kind of comprise the majority of the files that we saw. As a good threat hunter, I know that that is not nearly as interesting as the ones that are not the same as all the others. And so I took a single sample that I found on VirusTotal, which was different from all the rest. And there you see at the bottom the hash of that particular file. So when we look at this, we're looking at an HTML file. I pull it up in Linux VI, so I get lots of pretty colors. This is HTML. Any of you who've ever looked at HTML knows this is HTML that nobody will ever write. So you see that we have a bunch of directives. We see the light blue is a random string for a function name. Nobody does that. If you go a little further in the file, you get this absolutely gnarly JavaScript, which looks like this when you zoom the font on the screen. The highlights in yellow are JavaScript reserved words. Those are functions in JavaScript and words in JavaScript that are required. In this case, we are going to use those and the HTML keywords to form a rule. So looking at the rule that we formed, you see I chose the try, catch, and return keywords, and then I have a whole bunch of strings. Those are the ones that were in the HTML. And that very last one, that is a regex in Yara, and that is for anything that starts with a pound and has exactly 10 lowercase letters. And if you look at the condition, I have pound signs in front of those variables. Pound sign means count. So at least 3 occurrences of try, 3 occurrences of catch, and 3 occurrences of return, and all 26 of the S strings. So in summary, just to kind of wrap up and give you some final thoughts, I think I've shown it's fairly easy to take a thing or a group of things and find it with Yara. Trial and error allows you to be quick and dirty and get rules that just work. You're not looking to win a prize here. You're looking to find evil and squash it. These rules don't have to be elegant. They don't have to be efficient. They don't have to be the minimum number of strings or the exact right anything. They just have to work. If you are doing large volume scanning across like a file corpus, you can pre-select file types, and that will allow you to speed things up quite a bit. Because, for example, if you have rules for Excel files and you only send them Excel files, that is faster than making Yara search a whole bunch of files, which will not be true positives anyway. If you are using the Yara binary, you can ignore the performance warnings from Yara itself. I have done some tests, and some coworkers and colleagues have done some tests, and Yara will say this rule is slowing down scanning. It really doesn't mean it. If you see an error from Yara, you do have to correct that. That means it cannot process the rule. But if you see a warning from Yara, you can safely ignore that. So, shameless plug, we are hiring. So if you are in the Atlanta area, possibly also New York or Chicago, or even possibly London, please send me a direct message on Slack, and I will be happy to get with you and point you to our careers page for the InfoSec job positions. So thank you all for listening. Thank you to Sans for having me. And now back to Q&A.
All right. Thank you, Tony. So a quick question for you. I know this is something that I've kind of thought about throughout your presentation and plenty of times before. A lot of this kind of work revolves around, just practice, getting actual malicious samples and things that you can just try and see how it works. So do you have any suggestions for great sources for just loads of files or HTML, or what you might actually want to write these rules for so that people could, do 10 files of practice or something like that?
Let's see. There is Malshare. I think is one of the most positive, one of the most common ones that comes around. There are several virus sharing groups. There is one that's run by the abuse.ch people known as Malbazaar, I believe, which you can get downloads from. Those are two, and of course Virus Total, if your company happens to be lucky enough to have download access to Virus Total API. Again, I always caution people when you're working with live malware, especially Windows malware, if you've never done it before, please get some guidance before you do and be very careful. I can tell you with complete certainty, if you don't, you will infect yourself. Not that it's ever happened to anybody I know, but I've heard stories.
Of course, right? Yeah, I mean, my guidance for people on that is like, build a Linux computer and then put a Linux virtual machine inside that and download your samples into there and take snapshots so you can just revert it and it's not going to infect anything anyway in nearly all cases. So
right. And that Sans Sift VM, I still work with Sans Sift VMs pretty much every day. That's my OS of choice. Of course, I modify it and do other things which you don't usually do with a Sift, but I have tons of tools that I use, things that I borrow and get from other people. But yeah, always, if you're working on Windows malware, don't work on a Windows box, please. I implore you.
Absolutely. The other thing I was thinking of, is there, once you build up like a library of Yara rules, do you have any system you use for organization for all of these things once it becomes too difficult to remember everything you've done?
That's where the metadata and code commenting comes in. You can use surprisingly simple systems to track them. Excel spreadsheets and wikis are commonplace use all over for people who do hundreds and thousands of rules. That's on most Linux distributions you can install RCS, which is the old school revision control system. There are, of course, newer versions of that, and if you use at work various and sundry systems, Git or whatever, you can use that for revision control and change tracking and so on. You can get as professional as you like.
Is there any like a particular organization scheme that you've seen used? Like, do people, leverage like Like, it seems like it'd be really cool to be like, show me all the Yara rules for miter attack technique 1, 2, 3, 4, or for the delivery stage, or for anything like that. Have you seen a system that like lets you query things based on multiple variables like that? That seems like that'd be really cool.
Actually, Yara itself has that capability. I believe it's called tags.
Yeah, I think you can
When you
tag stuff, but I've never seen like an interface where you like load your things into it, and like a UI maybe would be really cool to say like, show me the delivery rules, boom, and then show me that. Of course, you can do it with text and like grep and all that, but I didn't know if there's a more formal way with more polish of doing it.
I don't believe anybody has created one. But yes, that would be really cool to be able to organize things in that way and have a nice GUI tool that just read your rule set and split it up for you and all that.
Yeah. So maybe a project for someone listening here. We got 1,900 people listening. So if anyone wants to jump on that project, there you go. There's a free idea for you. All right. Awesome stuff, Tony. Thank you very much.